something shows up. Now that we factor the denominators, we maybe can see that we have more in common than we thought. Before, if we wanted to add these, we would have to follow that kind of like old rule where you just multiply the first fraction by the second denominator and multiply the second fraction by the first denominator, right? And we get some really nasty stuff here because we're going to have 3x squared plus 3x here on the top and the bottom, and then 9x squared over 9x squared over here, which wouldn't be too bad, but again, we see there's more in common here than we thought. Okay? For example, 9x squared and 3x. Okay? I can make this 3x match 9x squared, right? What's missing from the 3x to make a 9x squared? Another 3x, right? I have to multiply 3x by another 3x to get 9x squared. So all I need to multiply by here okay? And now I will have a 9x squared in this denominator when I multiply those, right? What is this denominator missing now? The x plus 1, right? It does not have an x plus 1 in there at all, so we have to multiply by x plus 1 over x plus 1. Okay? So questions on any of that? This is a crucial step right here. All right? Yeah, David?
All right, so I have a completely different way of doing this.
Okay, can you hold off on until we finish this one, and then we'll go through your way.
All right, that's fine.
All right, and we'll see how it goes. Because I just don't want to mix too much up right now. I want to keep it one way. We'll finish it, and then we'll try an alternative. That's fine. That's fine. Okay. Any questions on this way? Any questions so far? Okay. Common denominator here again. The 3x, we can make it match 9x squared by multiplying by another 3x. This 9x squared, the denominator here was missing an x plus 1. And now we multiply this all out. Let's see here. So x plus 1 times 7. How do we multiply a 7 times x plus 1? What do we have to do there? FOIL it out or distribute, right? So 7 times x, 7x, 7 times 1, 7. And then the 9x squared and the x plus 1, we could FOIL it out. I'm going to leave it unmultiplied. And I'll show you why in a second here. We actually don't need to multiply out the denominator. And I'll show you why here in a second. Okay? Now, how about the numerator here? X times 3x. What's that going to give us? 3x squared. Very good. Over, and again, I'm going to multiply the 3x times the 3x to make the 9x squared that we need, and then I'm going to leave it unmultiplied, though I'm not going to distribute it. Because now that I see that I have the same denominator, I don't need to combine it anymore. Okay, so step 2 here, we just got a common denominator. Okay, look for missing pieces. In each denominator. Missing factors maybe would be a better way. Not missing pieces, missing factors. Okay, more mathematical. Okay, and then 3, add or subtract. In this case, we're going to add because that's what's between there. Okay, so 7x plus 7 plus 3x squared. Well, we're just going to put them together because there's no like terms to combine here. So we'll just have 3x squared plus 7x plus 7. I'm going to put it in descending order. Over the 9x squared times x plus 1. Just like that. Okay? And there it is. We're done. Okay? You could maybe check to see if this quadratic factors. I don't think it does, though. We would need two numbers that multiply to 21 but add to make 7. And I don't think such a thing exists. So I don't think it factors. So we're done. Okay? We're done here. This is our final answer. We combine like terms. Okay? Let's try another one. Let's try another one. Okay? Let's do x plus 2 over 2x minus 2 minus, so we're going to do some subtraction now, negative 2x minus 1 over x squared minus 4x plus 3. I'm sorry, we skipped over you doing your method too, but.
No, I answered my own question.
You did? Okay. So, David, what would be a good kind of first step? How should we kind of start this here?
I factor the denominator.
Okay, yeah, so we could, if we didn't want to like have to do very much thinking, it's going to be more work potentially, but not as much thinking, so it's kind of up to you. If we didn't want to do much thinking here, we could take this denominator and multiply the top and the bottom here by this denominator. And we could take this denominator and multiply the top and bottom here by this denominator. And that would get us a common denominator, but it's going to waste us a little bit of time, or be a little more effort that way.
Yeah,
Okay?
you're gonna have a bunch of things that cancel out.
Exactly. Whereas David said, okay, let's factor. So David, were you able to get the first denominator factor?
Yeah.
What'd you pull out? A 2. All right, so we use GCF to factor out a 2. And then we still have the negative 2x minus 1 over, and then did you get the second denominator factor?
X. Minus 1 and x minus 3.
Very good. Very good. Okay? We have to factor the second denominator like a quadratic. So you're looking for two numbers that multiply to 3 but add to negative 4, so that's negative 1 to negative 3. Now, what do we see that these two denominators already have in common? They already have an x minus 1 in common. So if we had done the simple way of finding the common denominator, if we had done the simple way of taking the full, if we had taken this thing and multiplied the top and bottom by this, we would have doubled up the number of x minus 1s that we already have. We don't need that. They already have an x minus 1, so that's inefficient. We're wasting, work that we need to do. Okay? What is this denominator missing? Only one thing. What is it missing? A 2. This denominator is only missing one thing. What's it missing? An x minus 3. That's it. Do you see it? Do you guys see it? This has a 2 here. This does not have a 2 as a coefficient, right? Or as a factor. This has an x minus 1. This has an x minus 1, so they both have that. This one has x minus 3. This is not. No x minus 3 in there, so we have to put one in. Okay? So that's all we're going to do. This we're going to multiply by x minus 3 over x minus 3. This multiplied by 2 over 2. Isn't that so much nicer? Isn't that so much nicer than multiplying this and the top and the bottom here by x squared minus 4x plus 3, and the top and the bottom here by 2x minus 2 over 2x minus 2? So much nicer. Okay? So I'm going to go ahead and FOIL out this x minus 3 times x plus 2. So it's going to be, I'll leave it in the pencil. So it's going to be x squared minus 3x plus 2x, okay, minus 6, over, and I'm not going to multiply out my denominator, and you don't have to. Okay? So this becomes this right here. And then minus, and here's my second fraction. Let's see, 2 times negative 2 is negative 4x, 2 times negative 1 is minus 2. And again, I'll put the same. Okay? Is it a problem that I have 2 times x minus 3 times x minus 1 in this denominator, and 2 times x minus 1 times x minus 3 in this denominator? Does that mean they're not like anymore?
No, multiplication, you can change whatever order you want.
Right. Multiplication, if it's all multiplication, the order doesn't matter, right? 2 times 3 times 4 is the same thing as 4 times 3 times 2, is the same thing as 3 times 4 times 2, is the same thing as 3 times 2 times 4. Okay? You change the order around. So this product is the same as this product. Okay? Now, we're going to have to subtract here. First, let me combine my like terms up here. I know this is like so much writing. Let's see here. Negative 3x plus 2x is minus 1x. Okay. And here's something else. I don't like subtracting fractions, right? Bless you. I don't like subtracting them because it's like, I don't know, I prefer to add. So to change this, I'm going to distribute the minus sign to my numerator. So I'm going to make this plus, and the minus sign will then distribute. So this negative 4x becomes a positive 4x. This negative 2 comes now to be a positive 2. Right, we only distribute to the numerator. If we distribute it to both, then we kind of have undone our work. We only need to do it to one, not to both. Okay, so yeah, the minus sign will only distribute to the numerator, not to the denominator. Okay, And I can explain that more if you need to explain more. I can show you why that has to be. Now you can combine like terms. The x squared has nothing else to combine with, so it's going to stay x squared. Minus 1x plus 4x plus 3x minus 6 plus 2 minus 4.
Oh, I did not. Okay, that's what it does.
Okay. Now, the numerator does factor.
I actually kind of find that funny.
The numerator factors. What does it factor to be?
I actually kind of find that very funny.
X minus 1 and plus 4.
So x minus 1 and x plus 4, that's right. Now why is that significant in this case?
It
That
cancels out.
it cancels out! That's right. Cancels out.
So it's 0?
So even with this
Hold on.
way that we did it, we still had to cancel out at least one.
It did, which is kind of interesting. I don't know, that makes me think that...
Wait,
That maybe
never
we
mind,
could have
never mind, never mind.
simplified
I
more
didn't see the
somewhere.
negative.
Okay.
I didn't see the thing.
Okay. Yes, that makes me think that we could have simplified somehow, somewhere else here. But I'm not entirely sure where. Because rarely does this happen, David. Rarely does this happen. This is kind of rare. This is rare. This has happened.
When
But
I
it
was
did.
working through it, I had a feeling that my final answer I would have to cancel out an x minus 1, but when I did it, I accidentally messed up on one of my terms, which was the plus 2, so I couldn't factor, and I was like,
Gotcha.
hey,
Right.
weird.
Yeah. I got you. Well, that's good intuition. So, right, and so Stephanie, you're okay about why the x minus 1 is just resulting in
Yeah,
1 there?
I did see that.
Okay. So there it is. The final answer then is x plus 4 over 2 times x minus 3. Okay? Now, if we were trying to graph this thing, okay, which I know we're not trying to do, but if we were trying to graph this thing, since those x minus 1's cancel like that, what do we know is going to show up at an x value of 1? What shows up here?
Hole.
A hole. It's a hole. Because these things cancel out, the graph of this will have a hole at 1. Okay? And in fact, technically, I should say that this is equal to this as long as x is not equal to 1. Okay? You guys don't need to worry about that. I'm not going to take points off if you don't write that. But I do think it's important for you guys to see it. You guys can follow along and understand, okay? In mathematics, all right, we take what we say seriously. We don't try and fudge stuff. We don't try and say, yeah, it's basically the same thing. I mean, sometimes we do, but oftentimes, especially this equal sign, when we say two things are equal, we mean they are exactly the same. Okay? I know when you you're writing and you read something and say oh, this is equal to this, and that's different meaning. But here in mathematics, we want these things to be exactly the same. But this thing is not exactly the same as this thing down here at 1. If I plug 1 in for x here, no problem. I get 1 plus 4, I get 5 times, and then that's going to be 1 minus 2, negative 2 times 2, so I get negative 5 over 4, or negative 5 over negative 4, whatever you want to get. I get a number. If I plug in 1 here, I'm going to get 0 in the numerator and 0 in the denominator. 0 over 0 is not the same thing as 5 over negative 4. Okay? So we say that these two things are the same everywhere except at 1. At 1, this thing has a hole, this thing does not. Okay? Alright. So that's that. Let's try another one here. Let's see if I can come up with something good. How about, yeah, this would be good. Alright. Let's try another one. Okay. How about 1 over 3x squared plus x over 9x squared minus 12x.
Give me a video.
Sorry, I'm off the screen. There you go. Thank you. Okay. So, Jake, do we have common denominators here? No. Can we factor any of our denominators?
Yeah.
Yes. Okay. Does the first one factor?
You mean like, yeah.
Okay.
Yeah.
How do you want to?
Can you explain like that?
So like can we divide anything out of 3x squared, I guess?
No.
Yeah, not really. I mean, like we can break it up. So I guess in a sense we can kind of factor. We can break it up if we wanted to, but not in the same way. Can we factor the second denominator?
Yeah.
Yes. Okay. So what does that second denominator factor to be, or what can we pull out from these two terms?
3x.
A 3x. Yeah. Okay. And let's see. What does that leave behind then if we pull out a 3x there?
This 3x or yeah 3x, right?
Yep. Because it'd be 3x times 3x gives us 9x squared.
And then would it just be 4?
Minus 4. Yep.
Oh yeah, minus 4.
Yep. But just 4 though. Yes, you're right. Because again, 3x times the minus 4 gives us minus 12x there.
Yeah.
Okay. Good. Very important. Okay, thank you, Jake. I'm going to go with someone else now. All right, let's go to someone who's here. All right, Jordan. Now let's compare our denominators here. Do both denominators have a 3?
Yep.
Do both denominators have... Ooh, what about the power of x? This one has x squared. This one has an x. So what's missing?
The squared.
We need this to be an x squared. So what should we multiply this by to get an x squared?
X.
Yeah, another x. So times x here. Okay, that'll give us an x squared, right? Okay. All right, Jordan, what about, let's see here. This one has a 3x minus 4. This one does not.
So we gotta multiply that by 3x minus 4.
Yep, so 3x minus 4 over 3x minus 4. Okay, there it is. Okay, thank you, Jordan. All right. So Stephanie then, 3x minus 4 times 1, well, we distribute the 1, but it's still going to be just what?
3x minus 4.
Yeah, you got it. And the denominator, I'm just going to put the 3x squared in front, and then the 3x minus 4, like that. And then what about x times x there, Stephanie? X squared over, and then the 3x times x gives us a 3x squared. 3x minus 4. Okay. Stephanie, do we have common denominators now?
Common?
You have a common denominator? Everything's the same?
No, wait. Oh, common denominator. We have one whole common denominator.
We do. So now we can add them together, right?
Yes.
And so what's our numerator going to be? We're going to have one fraction, and it's going to be over the 3x squared times the 3x minus 4. And what's our numerator going to be then?
X squared
Uh-huh.
plus 3x minus 4.
Good. And I like how you put that in numeric order. Oh, sorry, descending order by power. So you put, even though the x squared was at the end here, you put it out in front, and then the plus the 3x minus the 4 there. Good. Because that's a good way to put it. Okay. The numerator, does it factor?
Yes.
It does. Bless you. Is it helpful to factor it?
No.
No. So you don't need to factor it. You can leave it as this. If you can see that it factors, but it won't factor and cancel, right? Because the only way it's going to factor and cancel is if we get a factor of 3x minus 4. But there's no way that this thing's going to factor the 3x minus 4 because there's no lead coefficient of 3 here or some other thing that multiplies by 3. So we know it's not going to cancel out. So you could just stop there if you wanted to. Or if you factored it, you could stop here. That's fine too. That's not wrong. It's not wrong. It's just not helpful. Okay. Good, 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 good. Let's do another one. Okay, we'll do one more here together. And then I'll get you guys started on your assignment. Okay, so.
Any question?
Yeah, go ahead there, Greg. All right, x over x squared minus x minus 12 plus, oh, no, sorry, I don't want to do plus. Minus, I want to subtract now. We need to do the subtraction ones in a little while. Minus 5 over 12x minus 48. Okay. Josh, coming to you. I said I'm coming to you. You ready? It's okay. If you're not, I'll help too. Okay? This is our problem. All right. Can we subtract right now? Do we have a common denominator? No. So we're not ready to subtract. Okay, good. So I can't just go ahead and just put x minus 5. Can't do it. I need to get a common denominator. All right. Well, let's see here. I could take this denominator, the 12x minus 48, multiply the top and the bottom by that, and then take this denominator, the x squared minus x minus 12, and multiply the top and the bottom here by it, and then I would have a common denominator. But that's a big mess. It's a lot of multiplication to do. So instead, let's see. Can we factor this denominator here? Okay. We need to come up with two numbers that do you remember how to factor? We need to multiply to make what here? So we want to multiply to make, if you see here we have a minus 1x and then a minus 12 here. We want to multiply to make negative 12 and add to make the negative 1. Okay? So can you think of two numbers that do that? Multiply to make negative 12 but add to make negative 1? That's okay. I'm putting you on the spot here. Someone to help us out?
Do you know the factors of 12?
Numbers that multiply to make negative 12 but add to make negative 1. So for example, 2 times negative 6. That gives us negative 12, but it doesn't add to make negative 1. It's going to be, anyone got it? Negative 3 and positive 4? Close. Negative 3 and positive 4 would make negative 12, but that's going to add to make a positive 1. We need to be a negative 1.
Just switch your sign.
Switch the sign. There it is. Okay. So yeah. So the good news is these problems are going to give us more practice with factoring. The bad news is these problems are going to give us more practice with factoring. Okay. So we get to get better, but we also have to continue to, struggle some too. All right. How about the denominator here in the second piece? Can we pull anything out of 12x and 48? Is there anything we can divide out of both of those? Mm-hmm. Yeah, you can divide both by 12. Exactly right. We pull out a 12, and we're left with x minus, what is 48 divided by 12? 4. Good, yeah. Ah, thank goodness we did this. Look what we have. What do we have in common here, Josh? What do both these denominators have? The what? X minus 4. Right, okay. Very good. All right, I'm going to go to someone else, Josh. Take you off the hot seat. All right, Connor, can you help us out here, sir? Connor, can you help us out? Yeah, all right. So Connor, our first denominator here, we have our second denominator here. We want to get like denominators. What is this denominator missing that this one has? 12. So we're going to multiply this first one by 12 over 12. Okay. And what is this denominator missing that this one has? X plus 3. X plus 3. So we have to multiply by x plus 3 over x plus 3. Very good, Connor. Okay. Oops, off the screen. There we go. All right. So 12 times x, 12x. And then I'm just going to rewrite 12 times x minus 4 times x plus 3. And then 5 times x plus 3 is going to be 5x plus 15. I went ahead and distributed 5 times x, 5 times 3. Over 12 times x minus 4 times x plus 3. Again, I don't like subtracting these fractions. Yuck. Make it plus, and then just make these opposites. Minus 5x, minus 15. Okay, same change. But make sure you distribute the minus sign to all the terms in the numerator there. And now you can combine. 12 plus negative 5, 7. And then there's no other number plus negative 15, so it's just plus negative 15 there. Over 12 times x minus 4 times x plus 3. Okay. there it is. Okay, folks. It's going to be super important that we get good at this, okay? Because not tomorrow, but like the day after tomorrow, Wednesday, we're going to look at solving equations that involve this kind of stuff, okay? And so we're going to need to be able to be comfortable with doing this so we can be ready to then solve the equations, okay? So that's what we're going to use it for. Alrighty.
Are you basically telling us like we're gonna get an x or a x point and we have to find the y point, or we get a y point and we have to find the x point?
What I'm saying is we're going to have something that looks like, let me show you what I'm talking about here real quick. I'll show you what I mean. We're going to have something that looks like, and I'll show you like, well, okay. 2x is 3. I'll just put on the board up here.
Yeah, I wanna see if I remember this real quick. Cause I'm not gonna be here Friday.
Okay, well, we'll see it before you're not here. Like, you'll see it before Friday.
Alright.
So that's the good news. Equals something like that.
Oh, okay.
Sorry, I just made 2x here.
Denominator everything?
Yeah. Yeah. So what you got to do then for a problem like now we have an equation, right? So before we were just taking two things, adding together. How do you do that? Got to get a common denominator. Now we have these three things. We get a common denominator for all of them, which is a little bit trickier, right? When you have them, but what you can do is use the same kind of step here. You look and see, okay, well these denominators both have an x, but this one's missing an x, so we just multiply by x over x there. Okay. Here, this one's missing an x plus 7, so you multiply by x plus 7. And here, this one's missing an x plus 7, so you multiply by x plus 7. And then this has a 2, but neither of these have a 2, so you'd also multiply by another 2 here, and a 2 here as well. And then that's basically what you do. You have more than two terms, you just have to find that common denominator that way. That's all. There are other ways to do it too, but we'll worry about that when we get there. Okay, we'll worry about that when we get there. Let's just focus on adding and subtracting these things. So, what I'm going to do is assign you homework from out of our green books in the back there, okay, because I'm not really happy with the number of problems that are left over from the other book. All right, so what I will have you guys do, okay, on page 586, again in these green books, okay, so you have to go back and get one of those, okay, or take a picture at least with your phone. So on page 586 in the green books, okay, I'm going to have you do numbers. (17 through 23), the odds.